Hello, IK here. Welcome to LLM way of meaning. Machine learning, machine way of meaning. Here is, we follow only one token. Vocabulary file. Vocabulary file is a dictionary of vocabulary included. It is words what we use in artificial intelligence. Every word is one token, we can say, but also one token is question mark, exclamation, space, etc. And words, we follow now tomatoes word. In a vocabulary file, it is 890. Tokenizer translate by vocabulary file, translate a word tomatoes. It's coming from massive content. Tomatoes, it is 890, and the tokenizer enter in neural networks 890. And here is a stop. In neural network, have only number 890. There is no connection with the massive text. Neural network don't know nothing about text, about string connected to that number. Neural network see only number. When that process tokenization finished, disconnect tokenizer, vocabulary, massive text, disconnect from neural network. And the neural network is finished, locked and static, waiting prompt. But in this video, concentration on how LLM, machine learning, a large language model, how its way of meaning. Now, 820 number is neural network. What neural network work? Only statistic. And you can thinking, what statistic about this token, this number 820? But you must know that number coming here with the other number, and statistic is compare interaction. Every interaction between 820 with other, we say 30,000 token. 820 with other 30,000 token that we now would not be precise, there is an interaction. And it is a big time consumption because statistic work, interaction between all token and all sentences that numbers is create follow sentences in massive, and that is for an example here, how would be first, two second token, grow third, tomatoes fourth token, a question mark fifth token. And we will have in a neural network, we will have 123, 456, 789, 890, 891. You see, there is no point, there is no exclamation mark, there is no exclamation, there is columns, etc. Only numbers. But you see how is first, and what I said now it happened in 1536, a layer of neural networks. Every token is calculate statistics about one token go in 20,000 variables, what we call weight, what we can call parameters. It is variable. And save data in that variable, 20,000 variable, one token. And you can now imagine, you can now thinking what that can be. I said it can be, uh, for example, how many times is can be order list of the most present in this most number exist here in this layer. For example, technology layer. It is tomatoes. It is very rare in technology. Maybe nothing, never, and it in embedded vectors would be -1. I look at here, -1, -1 in column 1. It is dimension 1. It is technology, but it is all is number. Here is all number, and somewhere there is a vocabulary file and translation file. So somewhere exists that the number is technology, but here in neural networks and embedded vector is only numbers. And in columns 1, in dimension 1, it is, I said you, technology. There is a -1. It is the less possible. It is the less possible number here. And some ID 30,000, it lasts. There is a dimension technology 0.99. It terms very. There is a more and it is a top of in the top of the near the top of the order of the order list. -1. You see now, -1 in technology for 820 number. It means for a neural network, for a statistic, some parameter or neural network is also -1. And 20,000 parameters, there is some numbers. You can imagine a lot of things. How many think about token compare versus other token? How many things memorize in that parameter, in that 20,000 parameter? How number 820 in dimension in embedded vector give -1 in dimension in columns 1. So give 1 in dimension 2. It is maybe agronomy dimension. And in some dimension 1536, it is last dimension, it would be 0. Here is 0.425. Statistic like statistic in the newspaper, what we read about anything is saved in newspaper, print in newspaper, and we see that. So here, it is that all number is saved. And dimension 2 here, dimension 2, and the ID of token 891 for that statistics mean something, mean something. What mean? That in dimension 2, number 820 is very, very often in that massive content, very, very often in context agronomy. But in dimension 1, very, 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 very low. There is a no in that dimension. There is a no, nothing about that token not exist in technology, for example. But I must say technology and agriculture and agronomy, but it is don't exist in a neural network embedded vector. In neural network exists that number 820. There is vector dimension. In vector dimension 1, there is a -1. And vector dimension 2, there is a 1. And you look at 1536 columns, 36 dimension. It is a lot of what add. It is a lot of, and that content con, 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 context is very, very detailed. Resolution of context is very, very detailed. It is not from technology. There is a lot of context because and in every of that small segment of content, we have one number for concretely token. There is a 1536 number. And it is statistic about number. And statistic is it in real world, and it is job of statistic that number, and numbers and always numbers. And LLM, what is a large language model? It is a neural network embedded vector. And when process of learning, maybe 2 months, 3 months, 24/7 learn, learning is a process that in every sentence, in that every sentence there is an analyze of position, token to token, and other sentence and other sentence and million sentences, million sentences, 2 million, how many massive content is. We have that analyze about, we have 20 parameters memorize for every dimension, for every context, for every layer, 1536 layer. In every 1536 multiply by 20,000. It is total of how many variable there is one token. Only one token, but there is a 30,000 token. 30,000 token, it is equivalent 27 letters in our 27 letters in our ABC, but plus exclamation mark, question mark, etc. Point, etc. But it is ABC. Token is ABC. Token is ABC of LLM. of machine learning, of large language. It is 30,000 letters. But why don't use letters instead of words for token? 27, for example, letters, 27 tokens, and uh, uh, it is less token, less job for neural networks. It is, if you ask it, artificial intelligence will not know to say you, it will not know to say you this, what I say you. I say you because of meaning to people and meaning to. If something not meaning people, it's not meaning, and if we translate it in number, it's not meaning LLM, machine also, for example. But to us, meaning A letters, nothing. A letters have number, for example, 1, coming in tokenizer, coming in neural network, 1 letters. And how many, that letters, how many times would be seen? It don't say nothing, because letters E, letters A, letters E, any letters don't meaning nothing. To word, to man don't meaning nothing. A, nothing. But tomatoes, tomatoes word meaning to man. It is tomatoes. We understand the letters. We learn letters, but artificial intelligence don't know nothing about letters. Because of that, artificial intelligence cannot learn by grammar. Grammar is for men. And how produce excellent grammar neural network, but don't know for grammar. Because of that, statistics, 20,000 in one dimension, parameters. That statistic show that all relation, and on the fundament of that statistics, when generate that statistic, it is knowledge, neural network. The statistic will generate content to us. How? By statistics, token by token, token by token. And only job of LLM is what token coming behind this token in this context. In this context, and also it is a big job. Because of that, there is a trillion of parameters. Trillion of parameters. Because of that, there is a 1536, and the statistic is very, very impressive job working here. But what is impressed here, that we cannot know all, is that number, 20,000 variable, 20,000 variable. And I don't know, maybe there is a book about that statistics, and we can see what every parameter, every of that parameters, it is trillion, but is declared. It is a variable, it's declared, it is exist. They call it weight. Weight, it is excellent word, weight. How weighting this parameter, 820, how weighting? And we see weighting 1, -1, 0 point, etc. How weighting? And it is something about statistics statistic about that token, about that number statistic, and all about that one number inside of that massive content. All is contrary when coming prompt inside prompt. Okay, when neural network finished job, it means finished all statistic about every token in million and millions token in massive content. After finished process in a neural network, we have a 3 trillion parameters. Every trillion parameters there is a value. There is a value, and have been created, have been embedded vector, and embedded data set, embedding vector, token vector, and the neural networks finish job and stay locked. No learning more, massive text content what go in, no finished job, and it is now, from now, don't need massive content, but also don't need tokenizer and vocabulary file. But prompt don't need now during waiting, but when prompt coming in neural networks, in prompt go like massive content through vocabulary file, tokenizer, that prompt, convert, translate by vocabulary file, translate in numbers. And that numbers go in neural networks, and every number, it is one of 30,000. And 30,000, we have here embedded vector. And prompt, all token from prompt exist in embedded vector, in dataset token embedded vector. And every token, there is all brain what need to have in that embedded vector. Every token of our prompt would be embedded with vector, existing vector from dataset, existing vector. It is vector product during machine learning. And now we have in a neural network, and now we have a embedded vector for every number of our prompt, number of token in our prompt, and that vector guide token by token in a neural network. And in neural network, coming vector with 1536 for every token, and that means that token go fly like space aircraft through spaces it contest through spaces, and about depends about value, about dimension and value for that dimension, start create and other parameters. Neural is knowledge, must be knowledge with trillion parameters. It is big knowledge about number, and start produce from that neural networks, all that parameter, start generate content. And what generate content is also number. Produce sentences, but by number. And after that, it must be again connect to tokenizer. Tokenizer must translate that number in a word by vocabulary file. And on the screen, we see miracle. We see correct grammar, excellent response, excellent programming, excellent writing code, etc. And here is my explanation of LLM way of meaning, LLM way of meaning. And it is from first compute in the world. It means from first theory, maybe of computers. Maybe it would be, we can say, Boolean. Boole, Professor Boole, when somewhere in Scotland, have not in free times, there is no there is a time he had the time, free time, lot of, without electricity. It was 200 years before, and he plays some game, read the logic of Aristotle, and that sentences from that write it in a number, 1 and 0. One is zero, one is true, zero is no. And sentence can be true, can be false. And true, true, false, false. Dakle, start to play with the number. And in one side, there is a book with the letters. In other side, there is a 1010, 10, etc. And we call it Boole's algebra. And with Boole's algebra, constructed all computers first, computer second, etc. I think that first algebra was, first computer was Descartes. Descartes system, not binary, but never mind. We have a math Boole algebra for computers, and that math, when you learn Boolean math, we on the faculty in some year, we write that Boole algebra, it was the most important and I like more. You create, for example, how the less possible transistor can build this device for these goals. A minimal transistor for, and it is algorithms. It is like algebra. Algebra, we from one numbers and operation, we have a new numbers and operation. So Boole algebra also with math operation, we have a new numbers, and it is process of how we produce algorithm. But okay, back here. Here, for me, it is very, very interesting. LLM is like some transformer, like computer is. Transformer 110, Boole algebra, but some binary system, numbers, transforming all what we see on the screen. movie, colors, text, animation, all coming from 1101. So here, uh, every response of LLM, it is image, video, animation, text, voice, all coming from this neural network and embedded vector. Neural vector, network and embedded vector from that trillion variable, trillion variable. Uh, Variable is very, very powerful uh, because every variable is like our memory in our brain. And trillion variable, it is a lot for computers, clusters, for technology, and we see result of that. But I again can say now GPT number 5 is better than GPT-4, but in what is better? Would be less token in generative content. It is big news because we pay by token, uh, but also it means that response would be concise, more concise, very, very important, more concise, because response previous version it is extreme big, and I very, very often said something and ask from artificial, say yes or no only, yes or no only, and if it is no, I said okay, explain. But explanation is very, very, and I must say, not GPT-5 cannot. GPT-5 it means generate parallel, maybe 100, maybe 10, maybe 100 parallel generate parallel generate 100, for example, response. But after that, there is a process like here on the screen that 5 response. Only one must be only one must be shown on the screen. LLM must choose. It means that use one other. It is add, like it is add one other LLM who must now choose the best answer, and how created, but created by semantic searching. Semantic searching I will have in some of video in the future now. Semantic search is based on meaning, but on that numbers meaning, and it is not excellent response for us. Cannot GPT 5 cannot say you that letters nothing meaning to man, token words meaning to man, and what not meaning to man cannot be in any possible numbers and any possible big computers network give us produce some generative generative but that numbers meaning what create from that numbers that machine meaning is very, very long from our mass meaning. Because there is a trillion parameters, but in our head is analog number of uh, parameters. It means infinitive possible. Infinitive possible. I call it neural. I don't know this moment how we call it in our brain, but I call it parameters. How many in our brain there is a parameter? Infinitive. Every analog, and our word, natural word is analog, not digital. And analog means infinitive, infinitive, infinitive quantity of neural in our head. And you look at now infinitive uh, verse trillion. Trillion, there is no chance. There is no chance. And it is question, uh, yes, I think that uh, machine learning LLM would be near and near and near and near to our meaning, but never equal, never equal. And what would be that near and near and near and near to our, I can I don't see, because digitalization process until now is good for that primitive primitive jobs for robots, sensors, and now for this primitive LLM. Because LLM, what is LLM? LLM take all content through internet, Git repository, social network, and put it by tokenizer, neural network embedded in numbers. We see that process. But it is content from social network, from internet. It is like Google search, and it is like search engine process. And practically, LLM give us what give us Google search, but it is suited in grammar is it is suited in grammar correct sentences, grammar correct sentences by this process what we see now. But and we see response is on the level of search, Google search. But this number, neural network and embedded vector, create something very, very important, because we can communicate in our natural language with LLM. And LLM we can send to Mars in space. LLM will have in neural networks on the land we put in it all about that part, that all about world and the space, what we know. And the neural network can communicate with neutral language, but robots exist on the Mars long years before, but and send data to land, to home center, but LLM, if we add LLM, we can communicate. LLM is excellent for that that kind of work, and it is on that level. It is on the level of searching, and can connect it with the knowledge base, complete massive content is in neural network. And searching with that massive content uh, give us grammar correct communication, and that response can be connected, and we have communicate with that natural language on that level of search engine of content what exists what exists. Generate content don't means invent content, but men when men generate what go from man's mood, it was generated by that man, and it has meaning. It is original. It is original production. Uh, so we have people knowledge. What we all people knowledge is product of people. But here, generate generative content of LLM is something exists on the internet, and thank to that, because I don't need program coding, and of course thanks to LLM, what I have somebody with on that level existing knowledge, I can spoke, and coding in that level text, LLM is is excellent. It's excellent, and for our productivity, it means a lot. And now, how that steps GP5, and what next GP, how would be near and near, would be a smaller and smaller gap between LLM and us, man. I don't know. I don't know. But for now, uh, artificial GPT-5 cannot explain on the deep level, cannot explain you something on the deep level. And the teachers in the world would be last chance profession, last change profession, but it means every man's would be never changed by, because every man is teacher. Every man is a teacher. Every man there is own experience and own innovation, and with what LLM cannot compare. With what LLM there is no chance. Every man is teacher for LLM. Okay, look at slowly. I spoke slowly. Look at with your eyes, but ask yourself, thinking about what I present here, thinking about LLM, how play with number and serve as with the text. It is always like that. Database, relation database, is in tables, but nothing say to man. But when we query it from that tables, relation tables, when we query it, we see on the screen response what is understandable to man. understandable to man. It is something what is constant from numbers, from inside computers, and from tables of database. We have something very understandable to man, very understandable to man. And okay, I finished now this video. Thank you for watching this video.